I came across a Red Ice Radio video broken up into 6 parts of Wallace Thornhill in the public domain, and it is an excellent interview, outstanding information that is very important in my opinion, and I seen that it was just kind of languishing there in 6 parts. It's been on YouTube since 2010, so I wanted to put it all together and present it as one piece of work. All the credit goes to Red Ice Radio and Mr. Wallace Thornhill, who all has picked up the banner and has furthered the cause. Don Scott has a brief interview after Wall, and then the video will end with some advice for the future from Emanuel Velikovsky. So I give you Wallace Thornhill.
It's good to have you with us today. My name is Henrik Palmgren, and I hope that you are comfortable when and wherever you are in the world and ready for some eye-opening, mind-expanding and revealing radio, as we are going to go into the electric universe with our guest Wallace Thornhill today, who joins us from Australia. I hope that you're familiar with his work. If not, this will be a good opportunity for you to learn about some of his work and research. He has been working close with David Talbot over at thunderbolts.info, and he's one of the voices in the excellent Thunderbolts of the Gods DVD. He is also the author of the book The Electric Universe. We here at Red Ice have been following the electric universe theory with great interest over the years, and Wall, together with David, have been doing some really fascinating work and discoveries over the years. And as you might remember, if you have been with us here for a while on Red Ice Radio, we've had both Donald Scott and also Rens van der Sluis with us on the program before, who also are associated with thunderbolts.info. Wall's own personal website is hollowscience.com. That's the place to go to find out more about him and his material and his book, of course. But also do take a look at thunderbolts.info to see a lot of Wall's contributions there. So with that, welcome to Red Ice Radio, Wallace. It's great to have you with us, and thank you for joining us.
Thanks very much, Hendrik. It's a pleasure to be here.
Excellent. So much that I want to talk with you about, and I'm very excited to have you on the program with us. But maybe first, as a way of introducing you to our listeners a little bit, maybe you can tell us a little bit about your background first, and in terms of when you first got involved in researching the electric universe.
Okay. I'm an Australian, and I was born in Melbourne, in Victoria. And I went to university at Melbourne University and did physics and electronics. But in some respects, I was almost self-taught in electronics because while I was at university, I was fixing television sets as a means of raising a bit of cash. Before I went to university, I had read a book which I think could be said to be something that changed my life, and that was Emanuel Velikovsky's Worlds in Collision. And I was very surprised when I got to the university to find disinterest and even hostility towards his ideas, which were that the solar system has a recent history. When I say recent, I mean in prehistory, but remembered by modern humans. And I began a research year with an upper atmosphere group, but halfway through that year I decided that academia was no place for me because I wouldn't get any answers to the questions that I had, and I'd have to research them on my own. So I joined the computing industry and spent my career with IBM and with the Australian government. In part of that work with the government, I got to travel a lot overseas, and I was involved with the Society for Interdisciplinary Studies in England, and was on their committee when I was posted to London for several years. When I got back home, I got in touch with David Talbot, whom I'd actually met in 1974 at the International Conference on Velikovsky's work in Canada. At the time, neither of us knew precisely what the other one was up to. But in 1994, exactly 20 years later, I rang him to see if he had a copy of his book called The Saturn Myth, which dealt with a reconstruction of something that came out of a story that was not published at the time by Velikovsky about the memory of the planet Saturn as a sun, which is quite an odd concept. David said to me that he didn't have any copies of the book to sell, and he had no plans to republish it because he'd advanced so far beyond that it wasn't worth republishing. But he said that he was having an international conference in Portland, Oregon, and asked me if I had something to contribute. Well, as it happened, I certainly did. So I attended that conference, and I found what David was working on at that time. And I said to him that we should collaborate because what you've shown me are electrical effects in space. And from that point, our collaboration grew, and I spent some time in the US speaking at various conferences over there. The Thunderbolts group was set up. We began publishing books and DVDs and films and so on. And the result of all this has culminated in what you now see on the websites.
Excellent. It's a fascinating study also to see how Thunderbolts have grew and how a lot of additions have come to it throughout the years. And
yes.
Were you also interested in terms of the ancient, if we can call it that, then the ancient structure of the solar system in terms of Velikovsky and also what David Talbot then brought out, that you, if I put it this way, do you go in line with the catastrophe theory in that regard, that something happened in our solar system in past as well?
Yes, while I was at university, I spent a lot of time in the anthropology shelves at the university library, and I discovered that the evidence that Velikovsky had amassed for something strange going on in the solar system was, it just leapt off the page. It didn't matter what I read, whether it was referenced by Velikovsky or not. The picture was quite clear that something had happened. Consequently, I decided that I needed to find out what it was that we didn't know about gravity, about what controls the planets and their motions around the sun, because it was evident from what Velikovsky said that electricity played some role, but we don't see that happening today. And in fact, I was lucky enough to be able to take advantage of a trip to Washington, D.C. to ring Velikovsky at his home in Princeton, New Jersey. And he very kindly gave me an invitation to visit him, along with my family who were with me at the time. And so I got to talk to him about this question, because really the astronomers had dismissed his views out of hand because they said that it didn't meet Newton's laws of the dynamics of the solar system. And so I said to Velikovsky, what is it we don't understand about gravity? And he gave me a slim volume, which he was not keen to have republished, which talked about the cosmos without gravitation. And he was of the view that gravity itself was a weak electrical force. I took that idea away with me, and a few years later, I came across a small advertisement in the Scientific American. It was in 1981. And it was called the Journal of Classical Physics, and that interested me greatly because I felt that we needed to return to the common sense of classical physics and find out where we'd more or less left the rails, so to speak, in modern physics. And that gave me the clues. I wrote to the editor of that small journal, and we corresponded and visited each other, and from that grew the idea of the electrical nature of matter and how the gravitational force could actually be explained. Out of that, it took many years, though, to get over the idea that Einstein had in some way explained what gravity was. He hadn't. All he'd given was a mathematical expression which works but doesn't explain anything. And so I was looking for a simple explanation, and I think I found the essence of it. and it does explain how the planetary system could have been quite chaotic and yet achieve a stability which makes it look as though it's been wound up like clockwork.
Well, it's a fascinating theory, and we're definitely going to get more into it here as we go along. Maybe you can give us a brief outline of the theory of the electric universe, if we have some listeners out there that might not be familiar with this idea yet. Well,
it's pretty confronting. The first thing we say is that we do not understand the sun, and that the idea that it's a thermonuclear energy source is incorrect. And in fact, it works in much the same way as scientists on Earth have tried to recreate the energy of the sun by fusion experiments, where they pour a huge amount of electrical energy into this system to try and get a little bit of thermonuclear energy out. Well, stars do the same thing. They accept a huge amount of electrical energy from their environment, from the galaxy, and the result is a small amount of nuclear reactions and the creation or the generation of heavier elements, which we see in the solar spectrum. There was an engineer who was associated with Velikovsky and whom I consider to be a brilliant fellow, but unknown. And he pointed out that all of the obvious features of the sun have no place being there if you just use the thermonuclear theory in an effort to explain them. He said, if you look at it dispassionately, all of the features of the sun can be explained in terms of a gas discharge. And from this simple basis, he was able to describe all the features we see on the sun, the granulation, the spicules, the hot corona, and so on. So the first thing we have to get around is the idea that stars are not thermonuclear bombs somehow controlled and contained so that they don't explode. This also raises the issue then, okay, if the sun is powered electrically, where does it get its power from? If the galaxy has electric currents flowing in it, where do they flow and how are they generated? And the answer to that is that the radio astronomers have been able to map these current flows by the signals they give out in the radio spectrum, and they find that galaxies are strung like Catherine wheels on these huge intergalactic filaments. And so it seems that electric power from beyond the galaxy actually forms galaxies and stars themselves. This raises all sorts of other questions about the Big Bang theory and origins and so on. And what we can say is that we don't know enough yet to be able to even ask the right questions about origins. Our ignorance is so profound, since we've got so much wrong, that we have to start all over again. What we can say from observations is that the universe is of unknown age and of unknown extent.
So it's not, what is it now that they're up to 16 billion years or something like that? They throw out a number, but you'd refute that?
Well, all we can say is that there have been all sorts of anomalies with these pronouncements, like finding stars that appear to be older than the universe, and so on. It really is presumptuous of us to think that we can talk about origins, creation of the universe, and particularly when certain evidence is overlooked. Some of that evidence shows that redshift is not a measure of velocity of recession. Most of it isn't anyway. That redshift is actually associated with the age of an object. So that these quasars, as they call them, which are supposed to be at the ends of the universe and extremely bright, are actually quite close. They're associated with nearby galaxies, and they're faint because they are newly born. And there's a kind of a biological aspect to the electric universe, because the empirical evidence shows that galaxies, active galaxies, give birth to quasars, which then evolve into companion galaxies. And the evidence for this is, well, in my opinion, it's overwhelming. But when you see things through the conventional lens, you have to introduce things like dark matter and dark energy,
Yes.
and the expanding universe, all of these really nonsensical ideas, in order just to patch up the theory so that it appears to work. The electric universe doesn't require any patching. It just works on what we see, and it applies really just electrical engineering theory to the universe. And the best thing about that is that it works.
Would you also say that because I remember when we had Rens van der Sluis with us to talk about what he called plasma mythology, when he talked about
Yes.
plasma, he said that it was also scalable, meaning that you can actually replicate this in a miniature version, a microcosm level of this as well, so to speak. So in a way, I guess what you're saying as well is that we can do experiments here on Earth in vacuum tubes and things like this to replicate what actually is going on the macrocosm level. Is that correct?
That's precisely right. Hans Alfvén, the Nobel Prize winner in plasma physics, pointed out that plasma effects are scalable over at least 14 orders of magnitude and probably more. And that's sufficient to take you from the lab-sized experiment to the size of galaxies and beyond.
Well, it's really fascinating. I do want to talk a little bit about here as well in terms of some of the suppressed science. And obviously you brought up Emanuel Velikovsky. You mentioned Hannes Alfvén as well, the Swedish electrical engineer who studied plasma physics. You have a great paragraph on your website that says, if I have an underlying purpose, it's you who's writing this, in my life, it has been to watch for intellectual explorers who have been marginalized by their peers. They are often those who have the audacity to use their imagination, uncommon sense, and courage to challenge the paradigm paralysis institutionalized in Western science. And maybe we can talk a little bit more about some of those names. I mean, Hannes Alfvén, as I mentioned, okay, he got a Nobel Peace Prize, I think, but that was for something else, not in terms of plasma physics directly. And then we have names like Michael Faraday, Haltern Arp that you mentioned before our recording, William Herschel, and again then Emanuel Velikovsky. But why do you think that these fellers' work have been so vehemently suppressed throughout the years?
I don't know. It's an interesting topic, the sociology of science, and I have a file which you couldn't jump over on that very topic. I'm sure many books could be written about it. The thing is that we should maintain some kind of common sense attitude towards scientists and realize that they are driven by the same kinds of human triggers as everyone else, and their responses to information can be just as irrational as ours. And when you talk about the scientific method, which is often used as a blunt instrument to beat everyone into submission, there are as many scientific methods as there are scientists. So there is no such thing as the scientific method. There are certain standards that you're supposed to adhere to, but often those standards are not met.
So,
pardon the noises.
No worries. So it's interesting that in that sense that we always get fed by this idea that there is a consensus out there. I mean, I do want to ask you later, for instance, about global warming. We can talk about that separately, which is another one of these things where they claim that it's a consensus and all scientists agree, etc. But we never get confronted with the fact that these are only theories, as you mentioned before, in terms of some of the things that Einstein brought forth and so forth as well.
Yes.
Why do you
I think that's a very good point. In fact, one of my beefs about scientific programs shown on television is that the reporters often state things as facts when they should preface the statement with the accepted theory is, or scientists believe, but not that this is a fact, because all science is provisional, or it's supposed to be. Unfortunately, there is a lot of dogmatism that creeps into science now because you have the cult of the expert, it's been called. And the problem with that, of course, is that you have science being fragmented into multiple disciplines. And it gets to the point where the disciplines can't talk to each other in the same language. And in fact, even within a discipline, I have found at seminars that somebody who specializes in one area within a discipline has this sort of breakdown in communication, which is a significant problem. And I should point out that the electric universe grew out of an interdisciplinary approach, which is not taught in any university on Earth. In other words, we look at the possibility that the earliest recollections of mankind have something to tell us about astronomy, which we can use to test ideas and propose experiments today. And to also to save NASA a lot of money in asking questions that we really don't need to ask, and to ask ones that we do need to ask. So, you know, that's the whole thing, that the electric universe tries to bring things down to common language, common sense, and engineering principles.
I mean, there would be people out there who would argue and claim that the compartmentalization of these scientific principles are in place for a reason, actually. I don't know if you would agree with that, Wall. It seems to me like that is the case, that it's almost designed for a hierarchy, if you will, to gather all the knowledge at the top and keep the individual researchers kind of uninformed at the lower levels, because that's what's happening anyway. What do you think about all of that, Wall?
I think that is one of the consequences. The language used in scientific articles is so obscure and obtuse that you really have to work hard to try and understand what's being said. Sometimes the people who do the editorials and so on for Nature and Science manage to cut through all of this jargon and provide you with some insights, but it makes it very difficult for anyone to get the big picture. And when you're doing science, I think it's important to get the big picture first, so that you have some idea of how your ideas fit with other disciplines. Right now, you know, you can have a problem in one discipline. You don't tell the people next door who are working in another discipline that you've got these problems. And so those other people assume that answers they get from you are pretty much signed, sealed and delivered, and you can take them as gospel, when in fact there are a huge number of caveats and concerns about the so-called facts. And this is one of the things that I find quite often, that I get referred to papers that are supposed to prove that the electric universe is completely wrong or misguided. When I go and read those papers, I find that the certainty with which I've been attacked is not reflected in those documents. In fact, they tend to support my view that these things are still very much unknown and still under investigation.
One thing there that has happened then, obviously, is that if we go back into history a little bit and mention William Herschel again, he talked about the electric effects and so forth, and he collaborated with Michael Faraday, for instance, and it wasn't really until our knowledge about electromagnetism and electrical engineering came onto the scene that we started to connect these dots, so to speak. But why do you think that the electric universe theory have stayed off the map in terms of our educational system? Because it seems to me that the older people who studied this were kind of on the ball, so to speak, that they were heading somewhere with this theory, but then something happened. Do you know what that was? What happened there?
Well, it was an accident of history, I think, and that's what I've written in the last article I've just written for my website called Our Misunderstood Sun. And Herschel said in a letter to Michael Faraday, who at the time was the experimentalist working on electricity and magnetism, William Herschel said, "We stand on the verge of a vast cosmical discovery such as nothing hitherto imagined can compare with." And he was talking about a link that they'd discovered between magnetic storms on Earth and sunspots on the sun. So here was an intuitive leap which was on the right track. The electric universe shows how these things actually work. And as somebody pointed out, back in those days and up until the beginning of the 20th century, a lot of scientists were what you might call eminent outsiders. They were not actually trained in the thing that they became famous for. And I think in that article I point out that Herschel was in some other, or both Herschel and Faraday began in completely different pursuits, but ended up the doyens of the Royal Society in their particular fields of astronomy and physics. Nowadays, anyone who tried to do the same thing from outside a discipline would be pounced upon immediately, and they'd never become members of the Royal Society.
Well,
so this idea of the Renaissance scholar, I think, has gone out the window, and I think that's a great pity.
Absolutely, we're losing so much because of it, but that's why we're grateful for the kind of work that you, David, and many other people as well who are on the track in terms of the electric universe. And I think it's a fascinating theory, and just by reading it from a non-scientific point of view, because I have no background in terms of science, I'm just very interested in it. It makes more sense to me because it answers a lot of these questions that just that you mentioned before, that regular science or the mainstream theories have to basically things that they have to make up in terms of to explain gravity and dark matter and things that you mentioned before. And
yes,
what do you think then are some of the biggest, I guess, fallacies in terms of that? Is it our lack of understanding when it comes to gravity and also this injection of dark matter, or is there anything else big, so to speak, out there that are specks in the eyes of mainstream science?
Well, I think one of the popular ones is black holes. And we have another dissident Australian scientist who has done the hard work in the mathematics and pointed out that there were some serious mistakes made, and that black holes cannot exist, even according to the mathematics. Now, common sense suggests that it's a simple mistake like dividing by zero, because if you try and concentrate matter in a smaller and smaller radius or volume, as you approach zero, of course, the density goes up to infinity, and this is more or less what you are talking about with a black hole. There is no necessity for a black hole. The evidence for it is given as the outpourings from the centers of active galaxies, where you see these huge jets going from millions of light years out into space, funneling huge amounts of energy and matter away from the center of the galaxy, where the supposed black hole is supposed to be gobbling everything in sight. All of the activity in the center of an active galaxy can be explained in terms of electrical engineering and plasma physics. The problem is, and this is the historical accident, the understanding of plasma physics and the kinds of experiments required to be done to understand galaxies were not done until long after the standard model of the sun was in place. That accident is detailed in that article I mentioned, Our Misunderstood Sun. The important issue is, of course, that if we don't understand the sun, then we don't understand any star in the universe, and we can't go talking about the first few seconds of the existence of the universe when we don't understand anything about what we're looking at. So this is why I say we don't even know enough to ask the right questions right now to answer the big questions in cosmology. You know, where did we come from? Where does life begin? And all this kind of thing. We can't even ask the right questions about where would we expect to find life in the universe other than on Earth.
That's just incredible, and it's very fascinating in terms of the sun as well. I've been keeping an eye on this, and maybe you can talk a little bit about solar flares and coronal mass ejections and what those are. There's certain expectations that comes from NASA and other scientific groups who are studying the sun in terms of what they call the 11-year cycle and things like that. But right now, as far as I've understood, we're in one of these situations where they don't understand why the sun is so quiet, as it were. It should be more active at this point, I've heard, but it's actually not. Can you talk about that?
That's right. Yes. The solar cycle, as it's called, the sunspot cycle, is one of the big mysteries of the sun. It's not explained by thermonuclear theory. You would not expect a solar cycle or sunspots, or even the granulated appearance of the photosphere of the sun based on a thermonuclear model. What is actually going on is that the thing we call the sun is actually the bright photosphere itself, which in the electrical model is some distance, it's at the top of the atmosphere, if you like, of a body which is inside and is of heavier elements. So the sun has no thermonuclear engine at the center. When you look at a sunspot, you see a clearing in this discharge, and beneath is cooler, it's dark. Now, if energy was trying to escape from the sun, it should be much brighter if you were to part the obscuring layer at the top. And that's not what we find. So a very complicated theory had to be put forward about magnetic refrigeration and this kind of thing to try and make the sunspot cool when it should have been much hotter. So it's just simple things like this that point to the direction or the mistakes that were made in those early days. The other idea was that the sun had to have a central engine to blow it up to the size we see. But that makes an assumption that it's just a neutral ball of gas responding to the force of gravity. But if it's an electrical object, if it's an anode in an arc discharge or in a glow discharge, then what we're looking at is not the surface of an object at all. It's a glowing plasma phenomenon, like the neon glow in a neon sign, which can be at some distance from the electrode. Now, of course, we see stars which are bigger than the orbit of Jupiter or Saturn. And the question is, well, how does it blow itself up to that size? Well, it doesn't. That glow is an electrical phenomenon. It has nothing to do with the central body itself.
So I guess also as well that would explain then why the surface temperature is higher than in the core. Isn't that what they've measured or come the conclusions that they made?
No, you have this crazy situation where you have a core which is at millions of degrees, thought to be at millions of degrees in order to sustain some kind of thermonuclear activity. Then you have the photosphere of the sun, which is about 5,700 degrees, and then you go up into the corona where it's millions of degrees. So here you have the coolest spot is in between two hot spots.
Ah, that's right.
And it just cannot work. Eventually that cool spot must heat up to the same temperature as either the center of the sun or the corona. So they've had to cook up all sorts of weird and wonderful mechanisms by which somehow energy can get from the center of the sun out of the sun without heating the surface or the photosphere, and yet heat up the corona. And to do this, they invoke, the physicists invoke magnetism. Now, I had a very telling commentary made by the chief scientist of Australia at a meeting at the university here, where she said, when we don't understand something, we blame it on magnetism. And now, it's funny that scientists often have these throwaway lines at their meetings. That's why I attend so many of them, which you would never see published in any of their journals. But that is precisely what happens. Somehow or another, magnetism is generated, and they've never been able to show precisely how that happens. And yet the sun itself is just one ball of complex magnetic behavior, which is easily explained in the electrical model if it's an anode in a glow discharge, but has no business being there at all in the thermonuclear model of the star. We're talking about the cyclic nature of the solar magnetic field and its sunspots. And all of this too is explained simply by a varying current input to the sun. So right now we're in a position where the current is not changing. It's steady, but most of the time it is either changing in one direction or another. And that gives us the solar cycle, the change in magnetism on the sun and the movement of sunspots in latitude. Hans Alfvén himself drew the circuit for the sun many decades ago, but nobody's paid any attention. Alfvén himself didn't see the connection with the galaxy, but that's also been shown now in the discovery of these neutral atoms from outside the solar system, which all seem to come from this encircling, I suppose you call it a cylinder, around the sun.
Mm-hmm.
And the magnetic field outside the sun's the heliosphere, that's the big plasma sheath that surrounds the sun, well out beyond Pluto. The galactic environment also has this steady magnetic field, which was not expected in the standard model, but which was essential to the electric model. So we keep getting verification almost on a daily basis from discoveries from the spacecraft and also the new telescopes on Earth.
Oh, that's incredible. And so what, in terms of if we want to look at it from the point of view of predicting then, or trying to understand better so the solar cycles in order to, well, at this time actually both prepare here on Earth, because again, these major flares, when they do happen, can indeed upset our electrical systems here on Earth. Waves like pulsating EMF waves going out and all of that too. So does it make it easier to predict then when the peaks or dips and valleys of sun activity is supposed to happen if we look at it from the electrical universe point of view, or is it still a mystery what drives it and how and why it's more active at certain points?
Well, we know how current is transferred through space. It takes the form of filaments, and in actual fact, it follows the same engineering principle that we use with twisted pairs of wires, which radiate the least energy. That's why engineers use them for signal transfer and that kind of thing. And it turns out that nature does the same in the universe. So everywhere you look in space, at nebulae, anything that's glowing, you'll see this filamentary structure, which is quite striking, and it's not explained by exploding stars or shock waves and that kind of thing. Now, most of them are invisible because the power density and the matter density is so low that you can only pick up the signals with radio telescopes. It seems rather ironic that when the radio telescopes were first proposed, astronomers said, no, you don't need those. What would you need those for? Well, it turns out that they will be an essential part of the revelation of the electrical nature of the universe, because they can actually trace these intergalactic, these dark currents as they're called. Now, the sun itself is powered by these dark currents. So the means of finding out exactly what's going on in our immediate solar system environment is what we need if we're going to predict what the sun might do. And that will be, I think, done by people like the radio astronomers and perhaps these people who now have spacecraft which can detect these neutral atoms coming in from beyond the solar system. We need to know what's going on in the sun's environment, because it's the environment that controls the sun. It's not something from inside the sun.
You know, when you mentioned that that in most cases these the filaments or these twisted pairs, in that sense that you're talking about, that they're invisible.
Yes.
I don't know if you recall. I think it was back in 2006 when they discovered this kind of what they call the DNA or double helix, basically
right.
spotted out into space. Does that come into the picture here as well?
Yes. On occasions, if the matter density is enough or the electric current density is enough, the filament will glow. And when it does, you will see these long filaments, and in some cases where the seeing is very good, you can actually see the twisted pairs themselves. And this is what gave rise to the idea of the kind of DNA in space. And it is a fascinating thing that you see this fractal, this repeated patterns
Yes.
in nature. And the electric universe is a fractal universe because, as we said earlier, the plasma phenomena are scalable over an enormous range of sizes. So you can expect to see the same kinds of things from the laboratory up to the galactic.
That's fascinating to me. I mean, have you done any biological research in this as well, in terms of looking at the human body, for instance, as an electrical machine in that sense, pretty much, if indeed we are driven by the same rules and laws in one way? What do you think?
Yes, yeah. Yes, there is a pattern there. In my research into the nature of gravity, I came to the work by that fellow that I mentioned earlier, who had given a simple explanation in terms of real objects as to how gravity might work. And he said that every subatomic particle is made up of smaller charged bits, if you call them. If you can imagine that the electron, the proton, and the neutron are actually made up of smaller charged bits orbiting within the classical radius of that particle, then you have an object which is malleable. It can be pushed out of shape. It can be a football shape. It can be spherical. It can be squashed flat in one direction. And by just those simple deformations, he showed that you can explain magnetism and gravity. So as one simple concept, the explanations just sort of fall out of it. But the interesting thing is that if you are going to have the electron, for instance, which is probably it's much smaller than the proton and the neutron. If you say that is made up of smaller particles orbiting within that classical radius of the electron, then it turns out, just by simple calculation, that those particles must be travelling far in excess of the speed of light. He calculated that if you could release those particles to move in a straight line, they would travel from here to the other side of the Andromeda galaxy in 1 second. Now, this gives you a clue. It means that the electric force itself operates throughout the universe at near infinite speed. It means that in the electric universe, everything is connected. And this gets you to the idea of the interconnectedness of all things, and also the fact that the electric signaling that occurs operates near instantaneously. And one of the puzzles that I always had was that, for instance, if you have a tennis player returning a serve, if you relied on signals travelling along the nerves at a few metres a second, then you would never be able to return the ball. You know, your reflexes, your actions would be far too slow. It just couldn't be done. The human body seems to act as a unit. In other words, the mind, the body, everything is connected, and the signalling between the various components in the body seems to operate far in excess of nerve speed signalling. And according to this model that I'm proposing, it actually occurs at near infinite speed. There is another benefit of that, and that is it means that atoms that are assembled into a complex molecule will do a beautiful resonant dance, which means that it has a signal, if you like, which is available to the universe, and other molecules of the same construction will all sing the same tune. It'll be like a symphony all playing at once, but apparently the communication is perfect. However, it wouldn't be perfect if one object was moving away from another and the signals travelled at the speed of light. To be coherent and to be consistent, the signals must travel at near infinite speed, otherwise they detune by the Doppler effect. But according to this new model, they do not detune. The signalling remains perfect, even if they are travelling relative to one another. So, for instance, if there is such a thing as ESP and so on, it doesn't get detuned if one person is flying in an aircraft and the other one's stationary on the ground.
That's incredible.
The other thing is, and it should have been obvious to astronomers long ago, it was pointed out by the late Tom Van Flandern, the astronomer, that gravity itself operates at near infinite speed, far in excess of the speed of light. In other words, the Earth knows, if you like to put it in those terms, where the sun is right now, not where it was 8.5 minutes ago. and the same for all the other planets in the solar system. If that wasn't so, you would have a torque acting on the planets which would sling them out of the solar system in a very short space of time. You would have no solar system. And yet this obvious point doesn't seem to have got through to anyone. The most disturbing thing of all for physicists is that this means that Einstein's theories, his postulates, were wrong.
Yeah.
And in fact, they were somewhat illogical, and this is why people have such trouble in trying to understand what it was that Einstein's theories were trying to say. The simple fact is they don't make sense. And those who've tried to make sense out of them, go round and round in circles and finally say, oh, well, other people believe in it, so it must be right.
Well,
but if we can get rid of this business of worshipping the scientists of the past, I think we would go science would progress much faster. It's like Newton said, he had seen far by standing on the shoulders of giants, but the problem is to pick the right giant and make sure they're facing the right direction.
That's right. That's a very good point. I mean, that's incredibly fascinating to me as well in terms of both the fractal properties that you mentioned here in terms of the electrical universe, but also then how that actually would explain, if you will, then a lot of so-called paranormal. I mean, they're only paranormal because we don't, understand them yet. These phenomena, which has to do with the interconnectedness of either human beings or
yes,
up to the upper level of this in terms of planetary bodies and things like that as well. And
yep, even the grand spiral galaxies would not be grand spirals if gravity operated at the speed of light, which is a real snail's pace in the universe. It's a terribly slow.
Yes. Haven't they been able to? I don't know if you know this, but I mean, they had this rule or law there that nothing can go faster than the speed of light. But as far as I remember, they even had experiments here on Earth where they've actually managed to speed up the speed of light, so to speak, or increase the speed of light. Do you know anything?
They always explain that away as being a phase. The speed of a wave, it's the phase of the wave that travels faster than the speed of light. But really, it's the electromagnetic wave does travel at the speed of light simply because it's a disturbance traveling through a medium. It's like a stone dropped into a pond. The waves move slowly away from where the stone was dropped, and that is, in effect, the speed of light. The speed of gravity is the speed of the, if you like, just as a kind of a simile, is equivalent to the speed of sound through water. In other words, it's traveling far faster than this slow transverse disturbance. And electromagnetic waves are a transverse disturbance in a medium. You cannot transfer an electromagnetic wave through nothing. It must have a medium, which is what Maxwell said, but it was discarded by Einstein with no explanation as to how the electromagnetic wave was supposed to proceed. You must, if you're going to have an electric field in space, it's got to have a charged particle as its point of origin. You can't just sort of conjure it up and say that it exists in nothing.
Do we get any closer to the mysteries of the origins of our universe, or at least the matter or energy within, or electricity then within our universe, if we look at it from the point of view of the electric universe?
That's a good question. What we can see, Halton Arp, by the way, the astronomer, was the one who showed that redshift is related to the age more than it is to distance or the speed of recession. And based on his work, he came to the conclusion that the universe is much smaller than we think, and that we cannot see all that far anyway. And therefore, what we can see in our small part of whatever the universe is shows electric currents flowing in and out of this small region of whatever the universe happens to be. And beyond that, we are ignorant. We cannot say. So this is what I say. We really need to be a little more, or show a little more humility in our understanding, and be more questioning You know, instead of trying to conjure up the latest science fiction story to make the headlines and grab more funding, just show a little more humility. And I think this would actually help in getting students back into science. Right now, they're just staying away by the truckload. Because it's boring. You know, they're told that you need to know esoteric mathematics. You have to be a mathematical genius, and that most of the work's done anyway. All you have to do is just solve a few puzzles here and there, and we'll have it all. We'll have it all on the T-shirt next week, which is just nonsense, you know.
Of course.
And but it's a recurring theme. We don't learn from history. That's our big problem. If we were to look at the history of science, we would find that it was rather like Arthur Koestler's put it in his book, The Sleepwalkers.
Koestler is a magnificent author, by the way. Absolutely.
Yes.
If we round things up here for the first segment, and we'd love to continue talking more with you if you do have the time for us, Wal. There is one thing I'd like to ask you before we do that, though. In terms of signal transfer, you mentioned this instantaneous communication possibly going on then between bodies and so forth, and if indeed is a signal and if that signal is electric in its origin, if we can put it that way, there's I guess two questions that come up in relation to that. One is this that people talk about when the term free energy, they talk about 0 point or tapping into the field. And in that sense, that's what I'm reading into this as well, that this is about this instant communication. And do you think that it would be possible for us in one way to tap into the signal transfer in order to actually read the signal communication that is going on in the universe, if you will? I don't know if that's too much of an esoteric area to get into, but give us your take on that, Wal.
No, I think it is possible. It's a longitudinal signal. It's the kind of thing that Tesla was playing with. And I think that it is the only way, really, to communicate beyond the Earth, because otherwise electromagnetic signaling is far too slow. Also, it is the only form of signaling that isn't shielded by plasma sheaths and double layers in space. And this gets down to questions about why haven't we been able to hear from ET, you know, the SETI project.
Yes.
And I can tell you why. We're using the wrong signaling technique.
They would never use that if they're advanced, you know, in that sense.
Of course.
Yeah,
this is once again is another bit of hubris on the part of scientists today, thinking that our puny understanding of the universe is enough to be able to pontificate about where we will find life and how it would communicate.
Yeah.
We have a lot to learn.
Oh yes, absolutely. What do you say, Wal? Do you have more time for us? Are you up for doing another segment with us?
Yes, I think we can soldier on.
Okay, absolutely. We have so many more questions I want to ask you, but please then, a way of rounding up here the first segment for us, mention your website, mention the book and the DVD that you guys have out there as well, so people know where to go to read more and see and hear more from the perspective of the electric universe.
Yes, my website on holoscience.com, that's HOLO, the idea being that the science is more holistic and interdisciplinary. So holoscience.com will get to my website. My colleagues have the thunderbolts.info website, and they also have the resources and forums for you to join if you're interested, and a lot of activity. In fact, they have a picture of the day on that website every day of the working week, and it's quite an outstanding effort on the part of volunteers. The books and the DVDs and everything you'll find on that website.
Alrighty, again, there you go. Very, very good websites and links for you guys. Thunderbolts.info, and then Wal's personal or his own website, holoscience.com. Definitely go over there and check it out. But do join us here in the next segment here then for Red Eyes members coming up. Very interesting stuff indeed. Stay with us, Wal. Thank you so much for this first segment. Don't miss our two coming Eyes members. This is a very interesting continuation as we talk about Deep Impact, Temple 1, comets, gravity, discharge, lightning, sprites in the Earth.
found out eventually that astronomers, even ones from very, very well-reputed schools, the big-name schools, don't study electromagnetic theory. They don't really know much. They don't feel they have to know much other than gravity, the fluid dynamics, the nuclear energy and things like that. But when it comes to anything electrical, they kind of put their hands up and say, well, we don't really need to know about that. If you, as a graduate student, if you want to learn anything about E&M, you go over to the electrical engineering department and take a course or two, but you really don't have to because you don't need any of that. Well, as a result, they've been saying some things that are totally wrong. And I think it's only very recently that electrical engineers, at least some of them, are beginning to look over the fence kind of that separates these two sciences and to say, hey, you guys are all wet. You should stop saying some of these things. But electrical engineers, like any other kind of science or engineering, is fairly parochial. You know, we hesitate to open the door to the next room and say, hey, what are you guys saying in here? That's we have the feeling that, well, that's their field, and they can say whatever they want to say in their field. But that's not really the way we're going to make progress in the next century. If people are essentially saying that Maxwell's equations say one thing and electrical engineers say no, they say another. And that's where the collision is beginning to happen, and that's when I started to get into it, and I began to pay a little more attention to what astronomers and astrophysicists were saying. And don't get me wrong, not all of what they're saying is wrong. Clearly, but they've made some real bloopers, and they seem to continue to. And this is what really is driving me at this point, is even when they're told about it, they refuse to understand and just keep on inventing invisible particles and imaginary thises and thatses. And that's what sort of got my back up, and that's what was really the genesis of my book.
Yeah, okay. Yeah, interesting. And I guess some of these bloopers is stuff like, black holes and of course the redshift dilemma, I guess. But before we go there, I mean, in a nutshell, is it possible to kind of explain the electric universe theory?
Well, it's tough, but let me try to give you my dog.
Yeah.
I give you sort of a cursory overview. Is that we have lately, because of the advent of radio telescopes and our ability to go into at least interplanetary space with space probes that are able to measure charges, the presence of charges, the presence of electric fields, and that sort of thing. We're beginning to see that space is literally chock-a-block full of separated charge, which the name we use is plasma, electric plasma.
Yeah.
And plasma has certain qualities about it. It tends to form into cells. It tends to form into filaments and stringy things, and it has the properties that the forces that exist between particles within plasmas are orders of magnitude, literally 30 orders of magnitude stronger than the force of gravity. Gravity is one of the weakest forces that science knows about. It's weaker than even the nuclear forces, the strong and weak nuclear force. And so when astronomers see things, for example, you see a rotating galaxy out in deep space, and you look and you see how that thing is rotating. You look at the profile. How are the stars in the outer regions of that galaxy moving? It turns out that Newton's law of gravity is incapable of explaining what we're seeing. So that because of the new tools that astronomers are using now, not only radio telescopes but infrared telescopes X-ray telescopes, were able to utilize a wider range of the electromagnetic spectrum than just this very little narrow band, which we call the visible light.
Yeah.
Which is what we've been limited to for ever since astronomy got started after Galileo. So I guess the idea is that plasma cosmology. Well, let me go back to that rotating galaxy. The laws, the rules by which plasma operates give us a very one-to-one correspondence with that kind of rotation, that galaxy rotation. A good friend of mine, who was one of the directors of the Los Alamos National Laboratory here in the States, did I think it was his PhD thesis, or certainly shortly thereafter, did a simulation on a supercomputer of a bunch of plasma. He put in the rules of how plasma operates, that is Maxwell's equations and the Lorentz equation, and just duplicated the way that swarm of plasma. You could see it evolving into a galaxy, and it ended up rotating in exactly the same way, with exactly the same profile as real galaxies do in space.
Oh.
And Newton's laws will not enable us to explain that kind of rotation, but Lorenz's law does.
Donald, sorry to interrupt, but that's very interesting, because I've heard this theory regarding, dark matter, that they came up to this theory basically because the computer models that they were running on the universe, they kept, the model kept falling apart in these computers, and they have to basically add a whole lot of matter to kind of keep the structure together. Isn't that right? Have you studied this?
Well, there are two different things. There's dark matter or missing matter, and then there's dark energy, and they're sort of similar. In my mind, they're all fairy dust. That is, see if I can remember my acronym. Fairy dust is something like frequently invoked inventions that are I can't remember the acronym, but they're conjured up to defend untenable scientific theories. When your theory doesn't work out, well, you can invent an invisible, unmeasurable thing that just has to be there because we know that our theory is right.
Yeah.
And we measure this expansion of the universe. That's where the dark energy came from, is because the Einstein relativity will not explain the expansion at the rate at which it is perceived to be expanding. Whereas the dark matter or missing matter was to explain this thing that I'm talking about, the idea that the galaxies don't rotate as they should, quote unquote, if Newton's law is the only thing that's at work out there.
Yeah. So,
one of the things I should mention that I think I wrote to you about is that I mentioned Dr. Tony Peratt, who did this simulation of galaxies. His thesis advisor was I was going to say very famous, but he should be very famous, Swedish electrical engineer.
Oh.
His name is Hannes Alfvén. And
okay.
I don't know whether the normal walking around Swede in Stockholm, if you mentioned Alfvén's name, whether he'd say, oh yes, of course, or whether he'd say, who's he? I never heard of him.
I guess the latter is correct.
I think the best thing about an electric universe by far is the medical benefits it will bring people right away. Viruses give off a frequency, or they exist at a frequency, and they have shown, like Dr. Rife, that if they match the frequency of that virus, it kills the virus immediately, leaving the healthy ones alone. Nature is a master genius, liked fruit and vegetables. If one is sick, it will give off an electromagnetic signal to the birds and the ants. It's like calling all pests, come and eat me. Nature does that, and the pests show up and eat the bad ones and leave the good ones alone. But when they start messing with it, that stuff stops happening, and that's not good. That can't be good. I buy organic only. It's just crazy.
Velikovsky's proposed mechanism for the Universal Deluge was the transfer of water from the atmosphere of Saturn between 5,000 and 10,000 years ago. Whatever the mechanism, there were undoubtedly catastrophic floods during this period. Moving forward, Lonnie Thompson has assembled evidence from around the world of an abrupt climate change at approximately 3. Mo Mandelker compiled a wealth of evidence of catastrophic events and rapid climate change at this time, presented in a series of papers in our journals and also in book form. Similar evidence was also presented by others at our second Cambridge conference. Investigations at Tel Leilan in Syria by Harvey Weiss showed that the climate around this site suddenly became arid at the end of the early Bronze Age, resulting in its abandonment for several centuries. This also seemed to have happened elsewhere, and a layer of tephra particles indicated a volcanic event. However, some suggested that the prime cause may have been an extraterrestrial impact. Mandelker argued that we encountered the Taurid complex at this time. Marie-Agnes Courty found evidence that a dust layer at Tel Leilan and other sites in the Middle East had resulted from an impact, but no crater has yet been found. In the next millennium came the end of the Middle Bronze Age, the time of Velikovsky's Venus catastrophe, and later the termination of the Mycenaean period, which Velikovsky associated with the Mars catastrophe. As to the best way for young researchers to proceed in this context and to conclude this talk, I could do no better than to quote advice given by Velikovsky in a graduate student forum. What I want to impress upon you is that science today, as in the days of Newton, lies before us as a great uncharted ocean, and we have not yet sailed very far from the coast of ignorance. Don't persist in your idea if the facts are against it, but do persist if you see facts gathering on your side. In science, unlike religion, the great revelations lie in the future. The coming generations are the authorities, and the pupil is greater than the master if he has the gift to see things anew. Imagination coupled with skepticism and an ability to wonder. If you possess these, bountiful nature will hand you some of the secrets out of her inexhaustible store. The pleasure you experience discovering truth will repay you for your work. Don't expect other compensations, because it may not come. Yet dare.